today we are continuing with our new unit, which is higher termed polynomials, I believe. We are calling it higher degree polynomials is the correct term for it. And last week, we started looking at leading coefficients and degrees, correct? So, to review, if I had this as my polynomial, can you find the degree and can you find the leading term? Or the leading coefficient, rather. I'll give you a few moments to find the degree and the leading coefficient for this. And once you have done that, I will also be writing another polynomial up on the board that I would like you to find the degree and the leading coefficient for. Now that these two examples have been written, I will pause while you have a chance to work on this. If I row 1, person 2 would be Ethan. Could you tell us what the degree is? For the first one. We have a degree of 9. We have a degree of 9 because it is the highest exponent. So if we have a degree of 9, row 2, person 6, today would be Nate.
It would be -3.
We have a leading coefficient here of a -3, because if we're looking here, our exponent, our degree is 9. So we're going to look at that term because it's called the leading term. And if we're looking for the leading coefficient of the leading term, that's just the coefficient of our leading term. Okay, this second one is a little bit harder because it's not in general form, it's in factored form. If we are in factored form, row 6, person 5 would be Parker. Parker, did you manage to find a degree?
What?
You got 3? Okay, how did you end up with 3? Exactly. So here we have an x squared from this term here. And from this term over here, this term, we have an x. So we have an x squared times an x, that gives us an x cubed. So our degree is indeed 3. Okay, Parker, would you like to call on somebody? Okay. Row 6, person 2. Ian. We are trying to find the leading coefficient. Based off of what we were doing, 4 is super close. Do you know why it's 8 though? Yes. So we have this 2, and this 2 is also affected by this squared, so we have 4 here. Here we have a coefficient of 1, so you just have a 1. And here we still have this 2 out, which is our vertical stretch in our factored form. So if we have 2 times 4 times 1, we end up with 8. Okay. Today, we are going to be learning a few other things, but yes, first, George.
So for those ones, are you only multiplying with the x values?
Basically, all you want to look at here are the x values. So if you find it helpful to just cross these off, because you don't need those when you're looking for the degree and the leading coefficient, you can do that. Eventually, we will be looking at those constant terms at the end, but at this point, we are not. Yes? Okay. Right here, this 2 is a coefficient for our x value, right? So if we have a 2 here, this 2 is also affected by the squared at the end of the parentheses. So here we have a 2 squared, which will give us a 4 for this term. For this term over here, do we have any exponent over here? Nope. So all we have is just the coefficient in front of this x, which is 1. And over here, because we are in factored form, you just have this 2 that is also being multiplied by everything. And so since this 2 multiplies to everything here, then you have you have this 2 term times the 4 times the 1, and that'll get you 8.
Do you FOIL them first, those two?
So if they're in parentheses, let's say it's 2 times 3 minus 2 times 3 minus 1. Would you distribute this 2 to this and to this? If they're all multiplied together? You would not. So you just have to, this right here is just multiplied by both of these, but it's not distributed to each of them. If that makes sense.
Could you FOIL yours?
You could FOIL those first. If you wanted to, you could take our original equation here, and you could just factor everything out. But as we continue, we're going to get powers that are like 5. And would you want to FOIL out something that's 2x plus 4 to the 5th power? I don't want to. You can do it if you think that's your idea of fun. More power to you. More power to you. That's where I draw the line. Okay, what I would like to look at next are 2 different concepts. The first of them is something called end behavior. And end behavior is just a really fancy word for if we are looking at this graph right here that looks like this. And I look at this side, the left-hand side of my graph. If I'm looking at the left, is my y value going in the positive direction or the negative direction? Is it going up or is it going down? It's positive, so it's going up. On the right side over here, is it going up or is it going down? It's going up. There's your end behavior. If we look at this one, I'm just tracing it so you can see it a little bit more clearly. If I look at this, and I asked you, what is the end behavior on the right side? Who says up? Who says down?
Down.
Thank you for knowing your directions. Fun fact, my roommate, who is the same age as me, cannot determine left and right. So she does this, and if she needs to turn left in her car, she says, right. No. On her steering wheel, so you clutch the steering wheel with these fingers, and then you do the L thing, and she still gets it wrong even with the L thing. I mean, she is also from Vietnam, so she thinks a little bit differently. So, like, when she's looking at, they don't have her. No.
Georgia has a solution.
What is the solution?
Your radio is here, right? When you're driving,
There you go.
radio's on my right.
Her problem is she mixes up the L and the R. So, like, just like thinking about it, like split second, she's like, this is an R. It's an L. She's only been here for. Basically. But she was raised in Vietnam. So, which is, you know. Also. We can do another one like it, yes. At the end of the period, though, I would like to show you a video of what traffic looks like in Vietnam. It is quite interesting and very eye-opening. Okay, before we do that, though, there is another concept that I would like to talk about, and it is called increasing and decreasing. Show of hands, who thinks they can explain what increasing means? Okay, yes, Will. Okay, bigger. Awesome. What about decreasing? Quinn? It's when it gets smaller. Okay, if we are looking at this first graph right here, from here to here, is it increasing or decreasing? Who thinks increasing? Who thinks decreasing? I should specify. When we are looking at increasing and decreasing, you read it like a book, left to right. So if we're reading it like a book, left to right, now do you think this is increasing or decreasing? Okay, it is decreasing because from left to right, you go down. And that's down is decreasing. Okay. So this is decreasing. And the hardest part about this is that we want to represent this as decreasing using something called an interval. And all an interval is it'll be a set of parentheses, and in the parentheses, it'll just be the starting number and the ending number for when you are decreasing. So if right here we are decreasing, and we look, what is this number here? Can anyone see it on their iPad? Let's just make up a number. What seems like a good number, Ian?
30.
Keep in mind it's on the negative part of our x values. I'm going to go with -3 because that sounds like the best one I've heard so far. Okay, and the other thing with our intervals, we're just looking at x values, only x values. Okay, yes, there are y values, but we are just going to look and write the x values. So here, if we are looking at our decreasing portion here, it ends at -3. So I'm going to put -3 by my closing parentheses. Now I got to figure out where it starts. On this graph, once we reach the top here, does our graph just stop? No, it keeps on going on forever and ever and ever, right? So what is the x value to which it'll stop on the left? Never. So never, or forever, is just another way of saying infinity. But since it is infinity in the negative x direction, then it is negative infinity. So if we look over here, this starting point here, that's the farthest left that we started, right? If this is the farthest left that we started, that means that right here, if you think about your graph is going to continue to go this way as if you were able to zoom out of your graph, right? So if you are continuing to go this way, you are continuing to find values in the negative x direction. So basically, you can continue this graph forever in the negative x direction. If you can continue it forever in the negative x direction, the way that we say forever is just infinity. And if it's in the negative direction, it's negative infinity. Is it decreasing at -3? It's kind of up in the air. We're just going to use parentheses. So that is like the inequality way. So if you could also write this as x is less than -3. That is, these two are synonymous. However, I did want to introduce interval notation to you because more and more interval notation is what you'll be using instead of inequalities. I'm going to give me a moment. Okay. Based off of this, over here, are we increasing or decreasing? So we are increasing on this side. If we are increasing, I would like you to take a moment. We are increasing because you start from left and you go right, and it's always going upwards. So where will we start increasing? -3 indeed. And where will we stop increasing? Never, right? In terms of x values, do you ever stop running out of x values that you can put into your function? You do not. So since you can go forever in the positive direction, the positive x direction, you will end your increasing at infinity. Okay, this one is very confusing. So let's do another example. Show of thumbs. Let's do this example by ourselves, or let's do this example together as a class. Okay, we are going to try this one by ourselves, and I will come around and help people who are very confused. Okay? To help you out, let's color code which ones are increasing and which ones are decreasing. This first part here, is it increasing or decreasing? So if it's increasing, I'm just going to put that in black. So this is increasing right here. What about that next part? We're decreasing here. The next part is increasing again. And this last part here, we are decreasing. Okay, so I will pause and give you a few moments. Try and write in interval notation the different increasing and decreasing parts. Now that we have looked at this, let us first look at this first. Let us first look at the increasing. If we are looking at our increasing, what x value do we start with, George? We start with negative infinity, indeed. And, George, would you like to call in somebody to tell us where we end?
Let's go with the dice.
Okay. Row 5, person 1. Would you like to phone a friend?
Sure.
Okay. Dice or someone?
Yeah.
Okay.
So it's negative infinity to 0.5. I can't really. Oh, right.
Right there.
It's like -4.
Yeah.
It's like -4-ish. -3.5, -4. The numbers are kind of small. That's okay. Okay, so we have increasing from negative infinity to -4. Do we have another place that we're increasing?
Yeah.
Ian, would you like to call in somebody to give us that other interval?
May.
Just an estimate
Oh, that one.
for like from right here.
Negative. Well, I had negative 3.7. So it'd be -4.
Okay, we're just looking at increasing, so this black one right here.
Oh, we're on that one.
Yeah. I know that you're jumping ahead. That's okay.
Negative 0.8 to 1.
0.8 to 1. Okay. The numbers might not be exact, but we're kind of estimating here. And notice we have two different intervals for increasing. If you have two different intervals, in between your intervals, you have to write the and, because it's this interval here and this interval here. And the way that we write and in math is with a U. It's just with a U. Yes.
So, like, you know the one, the first one, you switched it around. So you, or wait, never mind.
Okay. If you think you got it now? Okay. Cool. Okay, now we have to look at our two decreasing intervals here. If we're looking at our two decreasing intervals, Nate, would you like to call on somebody to give us our first interval?
Okay. First one.
For decreasing.
The small one, right?
Yes?
I got negative 0.8.
Negative 0.8? Okay. And where does it go to? We want to go from left to right, though. So where should we start?
Negative 4.
Negative 4-ish?
Yeah.
To negative 0.8-ish. There's one of ours. We're going to have another one, so I'm writing a U, because the U means and in math. Foster, would you like to call on somebody?
Group.
Our last interval here.
1.
Goes from 1 to infinity. Awesome. Okay. I just wanted to give you a little bit of taste of increasing and decreasing. We're going to go more in, you are going to go more in depth with it starting tomorrow when Mr. Server takes over. Sad. But what I would like to do for the rest of today is the end behavior that we have looked at. Did you notice that with some of our graphs, we started both up, and with some of our graphs, we started with both of them, with our end behavior both going down? And if you look at the graphs that we were just looking at, didn't some of them start with sometimes one goes up and one goes down? There's actually a pattern to tell you how those end behaviors show. And so, I don't want to tell you the pattern, so I'm going to make you find it yourself. So the way that I'm going to have you find it yourself is I would like you to take out either a graphing calculator or Desmos on your iPad. And just take different polynomials. For example, x squared plus 5 is a polynomial, but so is negative x cubed minus 9, x plus 2. That's also a polynomial. I would like you to try different polynomials that have different degrees and that have different leading coefficients, and see if you can notice a pattern between how your graph changes based on the degree and based off of the leading coefficient. So you may do this in groups of 3 or 4 people, and I would like those to be groups of 3 or 4 people around you so you can get used to your partners. And I will pause while we investigate this. To discuss our results, what is one thing that somebody found regarding patterns? What do you think, Grace?
If it has an odd number, then it's like a squiggle.
So if your degree is odd, it kind of looks like this.
Yeah.
Okay.
The number is negative.
Then it looks like our friend the parabola. Awesome. Brian, what else did you find?
If the leading coefficient is negative, it's just crazy.
Okay, so if you have a leading coefficient that's negative, so say we have something that's negative and it's odd. What's going to change with this graph? It's going to flip like this. And if we had something that was negative and even, then we would end up like this. Let's think about that. If you have y equals x squared, what is your degree, even or odd? You have an even degree here. And is your leading coefficient positive or negative? It is positive. So if we have this, and this is just a parabola, right? So doesn't our parabola just end up like this? Now what would happen if I put a negative in front of my x squared? What would happen to my parabola? Wouldn't it just flip upside down? So now it would look like this. So the same thing here. Your leading coefficient, when I put a negative in front, what is your leading coefficient? Negative 1. So that means that we have a leading coefficient here of negative 1, which makes it flip. So if we wanted to sum this up, we have a nice table for us. And on this nice table, if we have something that is even, if it's even, it's either going to look like a parabola facing upwards or a parabola facing downwards. And if you have a degree that is odd, it's going to look like a cubic function, and that you're going to have one starting down and one ending up. Or you're going to have it flipped so that the left side is up and the right side is down. So now we just have to figure out if I am looking at the positives, if I have something that's even and positive, which of my 4 graphs down here am I going to turn up with? A, B, C, or D? If you are even and positive, write on your iPad, is it A, B, C, or D? And then show it to me. If we have something that has an even degree and a positive leading coefficient, is it graph A, B, C, or D? It's A. Okay. So we have graph A. And if we have graph A, what is our end behavior on the left? Up on the left, up on the right. Okay, now we're looking at the odd and positive. Is it going to be A, B, C, or D? Odd and positive. It will be C. That's the wrong one. C. And if it's C, what will our end behavior look like? Down, up. Okay, there are only 2 choices left. From those 2 choices, can you fill in the rest of your table here? I'll give you a few moments to do so. We want to fill in the rest of this table. We've had plenty of time to do so. So row 3, person 6 would be Frank. What did you get for the even negative? Down, down. Which of our letters was it? A, B, C, or D? It was B, which means this one must be D. So if we are looking for odd and negative, what is our left end behavior? And our right end behavior is down. Okay. Based off of this, if I gave you a problem like this, let's just quickly go through this together as a class. What is my degree for this polynomial? 3. So 3 is odd. And now we have a leading coefficient. What is our leading coefficient on that term? 1. And 1 is positive. So if we have something that is positive and odd, based off of our table, what will our end behavior look like? It'll look down, up. So you'll have a graph like this, which will give you down on the left and up on the right. Your homework for tonight is the second half of the quiz that you did on Friday. So you did the first 5 problems, and you submitted them for your first 2 tries. You have 2 more tries to do the other 6 problems. You don't have to do all of it, just the last 6 problems. Okay? That is all your homework is for tonight, and that is all the material that we are going to cover. So you have a few minutes to start that, and if you have any questions, let me know, but I will stop our recording here.